Okay, so welcome to the docent lecture of Dalia Abdelfattah, to become docent in technology. And welcome to all of you in the room, and also I hope a lot of people also available online. The procedure of today is that total time allocated to this is 1 hour. Within this hour, first Dalia will present her research during 30 to 35 minutes. After that, we open for questions. First, the topic representatives, then the pedagogic representatives, followed by the delegate from Docentnämnden. If we still have time, there will be open for questions from the audience as well. And the representatives attending this lecture is myself. I'm Björn Winnerås. I'm professor in environmental engineering and head of Department of Energy and Technology. We have the topic representative, Dilip Kativada, that is docent in energy and technology from KTH, the Royal Institute of Technology in Stockholm. Well, online, welcome. We have the pedagogic representative, Henrik Wiberg, that is pedagogic developer here at SLU. And then we have Docentnämndens representatives, Brendan McGee, docent at the Department of Water and Environment. We have Anna Schneider, professor at the Department of Molecular Sciences. And we have Tim Verweest, that is professor at the Department of Crop Production Ecology. And the faculty is represented both by the Dean, Professor Thorleif Härd, and the Pro-Dean or Pro-Decan, Professor Sala Lin. And now to the person in focus, Dalia. She has been working at our department since March 2021. She is originally coming from Egypt, and she got her master degree in agriculture engineering and her PhD in environmental studies, both at the University of Alexandria in Egypt. And the main focus of her current research is developing sustainable technologies for biofuel and bio-based materials. And she will now present her docent lecture, Sustainability of Novel Technologies, Acting Today for a Better Tomorrow. The floor is yours.
Thank you. Before starting, I would like to thank the docent committee for allowing me to present my research work today. It's a pleasure and an honor being here today. I would like to thank the subject expert who is joining online and the pedagogy expert. Thank you for your time. Then I would like to welcome you all to the presentation and thank you for making the time in your busy schedule to attend the presentation. I hope you will like it. The title of my presentation is Sustainability of Novel Technologies, Acting Today for a Better Tomorrow. Through the presentation, I'm going to highlight why it is important to study the environmental sustainability of novel technologies, how to study the environmental sustainability of novel technologies. Then I'm going to present a number of applications of my own research work and my future plans. In view of the limited raw material and energy resources on our planet, we have been looking for alternative renewable resources to close the gap between supply and demand. Biofuels and bio-based materials are a promising solution with a strong potential. However, new technologies are needed to be able to use this solution. When developing a new technology, we have to ask ourselves a very important question. Is this new technology environmentally sustainable? Are we creating something new, something revolutionary that will change the world? Or are we creating a problem that will impact future generations to come? The goal of my research is to investigate how to develop new technologies for the production of biofuels and bio-based materials in an environmentally sustainable way. We use an approach called system analysis thinking. We use a combination of tools and methods, experimental analytical, and environmental modeling. We use a tool called life cycle assessment that enables us to understand how the different stages of the technology impact the environment. Then we work together with the experts in order to reduce the impacts on the environment. The environment is a complex system. It is all around us. But when we talk about environmental impacts, most people think about climate change impacts. Climate change has gained a lot of attention in the media. But climate change is not the only environmental impact. As scientists, we have been trying to understand this complex system. One way to do it is by dividing the environment into different environmental categories. Some methods divide the environment into 16 environmental categories. Climate change is one of them. The interesting thing about life cycle assessment is that it can tell us how the new technology impacts the 16 environmental categories. When developing a life cycle assessment, we need to understand a lot of things about the technology. We need to understand the different stages. Then we need to understand the input of each stage. What kind of raw materials are we using? How much? When are we using them? What about the water? Are we using any kind of water? When? Energy. What kind of energy is used? How much? We also need to understand the outputs. Are we generating any emissions to air? How much? What kind? What about the liquid discharge? The solid waste? You see, the data collection and the life cycle assessment is usually the most challenging and longest stage. But out of the challenges, opportunities arise. And developing a life cycle assessment about novel technologies is an excellent opportunity for collaborations with other research groups that have the expertise about the technology. I was introduced for the first time to the concept of system analysis thinking and life cycle assessment through my PhD work at Alexandria University in Egypt. I was developing an energy and a waste management system for one of the largest textile companies in the Middle East. Then I was asked to assess the related environmental impacts. The ability to understand how the technology impacts the environment, then work together with the experts to reduce these impacts, was really interesting to me. I felt I'm changing the world. I can make it a better place. After that, I worked with several partners in the Middle East and in Thailand. All work was related to life cycle assessment of existing technologies. 2019, I started my postdoc in Sweden and started working with life cycle assessment of novel technologies. A new challenge, a very interesting one. In the next section, I'm going to present a number of applications from our own research work related to the novel technologies in the energy and transportation sector in Sweden and in developing countries. In Sweden, the transportation sector consumes about 25% of the energy and generates more than 30% of the greenhouse gas emissions. Petroleum products, mainly gasoline and diesel, use 75% of this energy, followed by biofuels, electricity, and natural gas. The first application is related to life cycle assessment of novel technologies in the aviation sector in Sweden. This is the global air traffic map. Yesterday. It's a bit crowded, right? You can see it's crowded in Europe, not above Ukraine, but the rest of Europe is crowded, right? Well, look at this air traffic and multiply it by 3. Yes, 3. According to the International Air Transportation Association, by 2050, this air traffic will be tripled. Can you imagine that? Can you imagine how much traffic is there? Can you imagine how much energy is consumed by this sector? Can you imagine how much load we are putting on the environment through this sector? Something interesting, something to think about it. Zooming into Sweden. In 2018, an initiation for a fossil-free Sweden started. A number of roadmaps and strategies were developed. One of them was related to the aviation sector. The aim of that strategy is that by 2030, all domestic flights will be fossil-free, meaning we will be using renewable energy in all domestic flights. In relation to the strategy, one of the most recent collaborations was conducted with the chemistry department at Uppsala University. The experimental team at Uppsala University developed a new technology for biojet fuel production. They genetically modified a bacteria, cyanobacteria, in order to produce isoprene, the main raw material for biojet fuel production. Then they wanted to understand how the development of this technology at the industrial scale will impact the environment. And here comes my role as an LCA expert. You see, it's very hard to visualize how the experimental scale will impact the environment with the industrial scale. I need to start by explaining what is system analysis thinking, how we will develop the life cycle assessment. Then I have to help them visualize how we will convert this experimental level, scale it up into an industrial scale. When you think about the industrial scale, it's totally different than thinking about an experimental level. You have to take a lot into consideration at the industrial scale that most probably you have never thought about it at experimental level. For example, where the technology will be developed. The location, the geographic location is very important. What kind of energy will you use? Most probably you have never thought about it at the experimental level, but it is very important at the industrial level. Our team in this project consisted of 15 team members from 3 different affiliations. We were a combination of PhD students, young researchers, senior researchers, industrial experts. We started by identifying which processes will be involved. We know the process at the experimental level, but now we have to identify which processes will be used at the industrial level. Then we had to identify the inputs of each stage, followed by the outputs. Now, a very important question: can we recycle, reuse any of the outputs again in the system? That is very preferable from the eco-friendly point of view. This is the initial flow chart. After that, we have to set the system boundaries for the LCA study. What exactly we are going to take into consideration and what not in the study. Then we have to agree on the different assumptions. It's a long process. This is the initial start flow chart. Once we agree on the flow chart, I do the environmental modeling. I assess the different environmental impacts of the processes. Then I identify the hotspots which process has major impacts on the environment. Then we work together according to assumptions and results in order to find solutions, make it a more eco-friendly, a more sustainable technology. And we do it again. We modify the flow chart, we modify the assumptions, we do the modeling, we check the results. The study duration for this life cycle assessment took more than 1 year. We worked together and we were meeting together on a frequently basis, a weekly basis. This is the final flow chart. It's a bit different than the initial one, right? You can imagine how much work we have put in it. Some of our results. This is a contribution analysis. You can understand from it how the different processes that we have taken into consideration impact the environmental categories. In this study, we have taken into consideration 10 environmental categories, the most related ones to biofuel production. An interesting result was this blue process has major impacts on the different environmental categories. This blue process presents the production of sodium nitrate, which is used as a nutrient for the cultivation of cyanobacteria. So in order to make it a more eco-friendly production, we actually suggest replacing it with another nutrient, some kind of bioproduct from another industry. Another interesting result, we actually were able to achieve 20% less in climate impacts from the produced biojet fuel. A very important thing we took into consideration was the location. We assumed that the location of the industrial scale technology will be in Sweden because the experimental one is in Sweden as well. But then it turns out after the LCA that we had to change the location. You see that technology is dependent on light, solar light. It needs high light intensity. At the experimental level, you can provide that through artificial lighting. But at industrial scale, it's different. We needed something eco-friendly, something more sustainable. So we suggested to develop this industry in another country that has solar light, like intense solar light through the year. By the end of this life cycle assessment, the scientific results were published in a good journal. Also, they were part of 2 PhD theses at Uppsala University. And the collaboration started. This LCA development with the beginning of a collaboration with the experimental team at Uppsala University. After the development of this LCA, I was invited as a co-applicant in 5 applications, all related to biofuel production. The next application is related to the life cycle development of novel technologies in the shipping industry in Sweden. We are currently working on a project in collaboration with the chemistry department and Arctic Research Center, both at University, collaboration with our industrial partner, Eco Biofuel Production Company. The project is related to biofuels production for Arctic marine shipping. This is the Arctic Circle. Imagine I'm holding the planet in my hands. Okay, and then look at the upper part. That's where the Arctic Circle is. This is the Arctic Circle. The Arctic Circle consists of 8 countries. Sweden is one of them. According to Sweden's latest strategy for the Arctic region, sea transportation is one of the major impacting issues that impact the climate and environment in Arctic. Why? You see, these are the shipping routes in the Arctic. These shipping routes are partially working during the year. Most of the year they are blocked with sea ice. But recently, because of global warming, these shipping routes became more open, which means more shipping traffic, more greenhouse gas emissions from the ships in the Arctic. And you see, it's a loop. We need to do something about it. A number of regulations were actually set in order to reduce the greenhouse gas emissions from ships in the Arctic. I started thinking, why not using biofuels as a replacement for this kind of conventional fuels? But then I had to think, which kind of fuels we can replace? What will be the alternatives? I learned that it is important to take into consideration the existing infrastructure, meaning the biofuel that we are going to develop should be compatible with the existing engines in the ships, with the existing storage tanks in the ports. A lot of things has to be considered. Also, what kind of technology? Which production route? So you see, there's a lot of studying here and investigation about which kind, what to do. But then I found out that Sweden is one of the top producers of the pulp and paper industry worldwide. The industry, in addition to the pulp and paper, generates a number of bioproducts. Some of them can be used for biofuel production. So I had to study the different bioproducts, the different biofuels, production routes. I'm going only to present one in this presentation. This is biodiesel production from tall oil. Tall oil is one of the bioproducts from the pulp and paper industry in Sweden. It can produce biodiesel, and the produced biodiesel is compatible with the existing infrastructure in the ships. So I had to study the process and then developing the life cycle assessment to assess the environmental impacts of the production and use of biodiesel in the shipping industry in Arctic. Then I compared it to the two of the most common used fuels in the Arctic nowadays, heavy fuel oil and marine gas oil. These are some of our results. You see the contribution analysis. You can see from it the impact of the different stages on the environmental categories. The blue process, or the blue stage, has the highest impacts has high impacts in the different environmental categories. This blue process represents the production of methyl alcohol and sulfuric acid, which are used for the production of biodiesel from tall oil. And in order to make it a more eco-friendly one, we suggest using alternatives or a more efficient production process. Another interesting result was that we can actually use a blend, a mix of marine gas oil and forest-based biodiesel. Using this kind of mix will reduce the overall environmental impact, the different environmental impacts of marine ships in Arctic. We are still working on this project, looking for alternative technologies and routes. But one of the important stages in the upcoming time will be to collaborate with our partners at University in order to assess the social and economic impacts of biofuels production for Arctic marine shipping. The third application is related to life cycle assessment of novel technologies in the road transportation sector. In developing countries, cities in developing countries have two major sustainability challenges: the large amount of food waste and the dependency on petroleum products in their transportation, in their local transportation. Our case study was Mumbai city, with a population of more than 21 million inhabitants, large amounts of food waste, and the local bus fleet depends on diesel and natural gas. We developed a hypothetical scenario where we can use the food waste from Mumbai converted into biomethane for the bus fleet. We depended on an existing technology in Sweden. The system consists of 9 stages. In the first stage, the food waste is collected, then processed. It goes to anaerobic digester, where part of it is converted into the raw biogas, and the sludge is used as a biofertilizer. The residual biogas is upgraded, compressed, and used in the local bus fleet, while part of it goes into the heat and power plant, and this energy is used again in the system. We compared the environmental performance, the environmental impacts of producing and using biomethane from food waste, and compared it to the production and use of natural gas and diesel in the bus fleet. And you can see that the environmental impacts of biomethane is better in all environmental categories than the other two. For example, in case of global warming, we achieved 60% reduction. We can also save more than $99 million by using biomethane from food waste, replacing natural gas and diesel. This case study can be implemented in other cities that have the same conditions. For my future plans, my short-term goal is to keep exploring alternative technologies and feedstock for biofuels production for transportation in Sweden and in developing countries. We're still collaborating with the chemistry department at Uppsala University to find alternative technologies for biojet fuel production for aviation. We are also developing an interesting project related to green hydrogen production from food waste in Sweden. Another interesting project will be to study the potential of using biofuel from potato waste in developing countries. My long-term goal, I'm looking forward to work with prospective life cycle assessment for novel technologies. In the life cycle assessment that I currently employ, we can understand how novel technologies impact the environment on the present time. With prospective life cycle assessment, we add a new dimension, the time dimension. We can understand how the novel technologies will impact the environment on the future, and then try to mitigate these impacts from the present time. Last but not least, I would like to thank my head of department and my group leader. Thank you so much for your support. My colleagues who came here today, thank you for coming. My collaborators and our research founders. Thank you.
Thank you very much for an interesting discussion. Now I leave the word to our Dean to close this session.
Thank you, Björn. And thank you, Dalia, for a wonderful lecture.
Thank you.
Really. And I was impressed by when Henrik had this question about planning, and you just threw up this slide, well animated, colored, everything. You know, I've probably been to 100 docent lectures, and I've never seen this before. Have you on docent board, or Henrik? No? No?
Okay, thank you.
See? Right, so we are very proud of you, Dalia.
Thank you.
And as a token of our appreciation, I will hand over some flowers.
Thank you. Thank you so much, I really appreciate it.
Thank you, expert reviewers. Thank you, docent board. Thank you all for coming and viewing online. And I hope to see you here in 30 minutes.